In this warm-up, you're going to state whether they are rational or irrational. You do not have to evaluate them. The square root of 3. 1 squared is 1 and 2 squared is 4. So since 3 is between 1 and 4, this is irrational. It does not have a perfect square answer or an integer answer. The square root of 18, that's between 4 squared, which is 16, and 5 squared, which is 25, so this is also irrational. The square root of 121 is exactly 11, so that one is rational. Remember, to be rational, it has to repeat in its decimal form or stop. It could also be written as a fraction. Continue working on 4, 5, and 6. Indicate whether the value of x is a solution to the given equations. If we plugged in 1, is 1 squared equal to 1? Yes, 1 times 1 is 1. So yes. Is 1 squared, 1 times 1 is positive 1, equal to negative 1? No. 1 squared is 1, and 1 plus 1 is 2. 1 cubed, that means 1 times 1 times 1. And that does equal 1. But 1 times 1 times 1 is going to be positive 1, not negative 1. Negative 1 squared. Negative 1 times negative 1. Two negatives multiplied together do make a positive. They do not make a negative. We just saw that negative 1 squared is 1. And if we add 1 to that, it gives us 2. Negative 1 cubed. These make positive 1. And positive 1 times negative 1 will give us negative 1. So no, it doesn't make positive 1, but yes, it makes a negative 1. For problems 2 through 7, solve the equation. Identify all solutions as rational or irrational. So to undo a square, we use a square root. X can be positive 5, or it can be negative 5. Remember, negative 5 times negative 5 also equals positive 25. Both positive and negative 5 are rational values. Here we're going to square root to get rid of the square. The square root of 81 can be 9 or negative 9, which is also rational. X equals the positive or negative square root of 35. But there aren't any whole numbers that we can multiply together to make 35. 6 times 6 is 36, which is too high, and 5 times 5 is 25, which is too low. So this one will be irrational. H is the positive or negative square root of 110. Now 10 times 10 is 100, but 11 times 11 is 121. So this is in between 10 and 11. And since it's not a whole number answer, it is also irrational. The square root of 144 is 12. So positive or negative 12. 12 times 12 is 144, which makes this rational. The square root of 27. The closest ones would be 5 squared, which is 25, and 6 squared, which is 36. But there isn't a perfect whole number for the square root of 27, making this irrational. For problems 8 through 13, solve the equation. Identify all solutions as rational or irrational. In this one, we're going to use a cubed root to undo the cube. Since this is an odd exponent, it's only going to have one answer, either positive or negative, but it can't have both. So 3 times 3 times 3 makes 27, and that is rational. The cubed root of negative 125. That would be negative 5. Negative 5 times negative 5 makes positive 25. And if we multiply by another negative 5, that gives us negative 125. Negative 5 is a rational number. This one is irrational. 1 cubed is 1, and 2 cubed, 2 times 2 is 4, times 2 is 8. So this is between 1 and 2. We just saw that 2 cubed is 8, but negative 2 cubed is negative 8. And that is a rational. Negative 2 terminates, or you can think of it as having repeating zeros. Two cubed was 8, and 3 cubed is 27. So the cubed root of 25 is going to fall between 2 and 3, but it is irrational. The cubed root of 38 is also irrational. We saw 3 cubed was 27, and 4 cubed is 64. So 38 will fall between 3 and 4, but it is not a whole number. Dylan solved the equation x cubed equals negative 64 on his homework, but he made some errors. His work is shown. Help Dylan correct his math homework. So he said x is equal to negative 8 or x is equal to positive 8. It looks like Dylan was thinking of the square root of 64 because 8 times 8 is 64, but that would be the squared version, and we have the cube. So to correct his homework, we need the cubed root of negative 64 is negative 4. Since it's a cubed root, there should only be one answer, because positive 4 times positive 4 times positive 4 is positive 64. But negative 4 times negative 4 times negative 4 is negative 64, and that's the one we're looking for. So we're going to say Dylan needs the cubed root instead of the square root. The solutions, or the solution, because there's only one, is x equals -4. For problems 15 and 16, solve the equation and show all steps. To start, we will subtract 1 from both sides so we can get our variable by itself. And then since it's being multiplied by 2, we undo that by dividing by 2. 16 divided by 2 is 8. On number 16, we again start by subtracting the 1 to get the variable piece by itself. This time, x is being squared. So to undo that, we will square root, leaving us with x, because a square and a square root undo each other. And the square root of 16 is 4. 4 times 4 is 16. But we can use the positive or negative version for squared values. Identify all solutions as rational or irrational. All right, so we're going to subtract 2. X squared equals 9. Square root both sides. X equals 3 or -3. 3 times 3 is 9. -3 times -3 is also 9. And those are rational because they terminate, they stop. Subtract 4. M squared equals 10. Square root both sides. M equals the positive or negative square root of 10. 3 times 3 is 9, and 4 times 4 is 16. So M is not going to come out to a perfect square, which means it will be irrational. This time we add 8 to both sides. P cubed is 49. Now we take the cubed root of 49. In this one, 7 squared is 49, but 7 to the third power is not 49. The closest would be 3 cubed for 27 and 4 cubed for 64. So P is equal to the positive cubed root of 49, and it will be irrational because it's between 3 and 4. Add 6 to both sides. That would give us 125 and r squared. Square root both sides. A cubed root of 125 is 5, but for a square root, 11 times 11 is 121, and 12 times 12 is 144, so it will be between 11 and 12, and it will be irrational. Make sure your warm-up is complete and your workbook is filled in. Have a good rest of your day.